Scatter plots. What's a scatter plot? Okay, that's part of. Who else? What's a scatter plot? Sid. It shows like a bunch of points, right? And are all the points like on one straight line? Exactly? Nah, not necessarily, you know. But if they are pretty close to being on a straight line, don't play with the water. Right? If they are pretty close to being on the straight line, what do we call that? Correlation. Right? If there's a correlation between the data, then it looks like they kind of fall on the same straight line. Like we saw yesterday, right? If you have the more hours of study was a positive correlation with your grade on the test. The more you study, the better you do, right? The more hours you watch TV had a negative correlation, right? So that's the starting point. Now, if it looks like there's a correlation, then we ought to be able to make a line that approximates the data. And that's what we were doing yesterday. That line is called a best fit line, or it's called a regression line. If you go to your calculator, we're going to be doing this today, so you need to kind of pull this up. I might not hit it that time. There we go. Again, if you go to the stat menu and arrow over to the calc, you notice we started with number 4 on that list, which is lin reg. Lin is for linear. Reg means regression. So when you make equations to approximate data, those are called regression equations. That's a statistical term. For us, it's also just called best fit. It's the best line we could do drawing a line through that data. So what we did yesterday is we said, okay, let's make the, does that look right? Let's make the equation. But what gets added today, and this is section 5.7, the next one is, then you use that equation to find the value for another x value. So first we're going to do the same thing we did yesterday. Let's make a scatter plot out of this data right here. So let's remember, what are the steps so that you can enter the data? Stat edit. Okay, so we want to do stat edit. That's this one right here. Stat edit. So do that. And where are you going to put the x's and where are you going to put the y's? Yeah, so this first one should go under L1. The second one goes under L2. Okay. You know, they didn't say, like in this problem in the book, how to do this. Like, do you use 1993 for the year? Because a lot of times they'll say specifically, use the number of years since 1993 or since 1990. You don't really have to do that. You could just use 1993 through 1996. But unless we're all doing the same thing, our answers aren't going to look exactly the same. I mean, we'll get the same answer at the very end, but our lines will look a little bit different. So let's just use, like it is right here, let's just use 1993, 1994. Those will be your L1 values. And then we'll use the L2 values just as they are. Yes?
Yeah, it's not working.
Okay.
Is it because the numbers are so big, Mr. Callahan?
You did you zoom 9?
Yeah.
Did you turn on the plotting of points?
Oh, yeah,
Second y equals 1? Yes, there is a decimal right there. Second y equals 1. Okay. But again, if you want to look at the data, you got to do the second y equals 1. And then do zoom 9 so it zooms to those points, right? But you don't have to look at the data for this one because it told you to use a line. So it's actually, we don't have a decision to make by looking at the data. Okay? So how do you make, once you've got the data in, how do you make the equation of the line? Right? So stat, calc, which is an arrow over to the calc, for, and then you're going to hit enter a whole bunch of times.
I'm sorry.
Okay, now, once you've got your regression equation, right, which was made using just those 4 years, you can use the equation to estimate, well, what would have been in the years that are not listed? Like, what would it have been in 1994, since that's not in the table? Okay, well, then plug in 1994 for X and calculate it. Right? That's why you want to, like, write the equation down and have it there so you can use it for a calculation. You can see I did that here. Plug in 1994, and I got 16.9 million CDs shipped in 1994. Quiet, it's too loud.
Did you see my grades?
Okay. Okay, let's try another one. Here's another one. Well, here you go. So once you got that equation, you could use it to find, even for like years that were beyond what were measured, like in 1998, figure out how many CDs would have been shipped in 1998 and 2000. Just plug in X equals the year and calculate. See what you get. Well, I would write down the equation and then just substitute. I mean, you're going to use your calculator for sure.
If you're using this equation here, what? Sorry, here? You get what? No.
Everyone's tongue is right.
No.
Not naturally red. That was not naturally red. That's not red. No, yours is like hot Cheeto red.
Okay.
Oh, I know. My tongue is naturally back.
More.
28,000.
Okay, so you can, once you made your equation, you can use your equation. Quiet. Okay, you can use the equation to make estimates, predictions, right? Usually the word prediction be used like if it's beyond the last year. Actually, the word they use for that is extrapolate. When like we did 1994, which is actually just a missing year in the data, that's called interpolate. But this section is really about predictions. In either case, right, you enter the data, you make an equation, and then you plug in for the X values. So let's try one more time. This table shows the median floor area of a new single-family house in the U.S. during 1995 to 1999. Right? Make the equation, enter the data, and then make the equation, and then use that equation to predict the floor area 2000 and 2001.
We just do the last two letters, 995.
Yeah, it doesn't. you could use 95, 96, 97, 99. Just make sure when you plug in, actually that won't work. Then you'll have to use 100 and 101. Yeah.
Well, what about the first one?
Just use 1995. Right, so here's your L1. Here's your L2. Okay, so there's your, those are the values you should have gotten for 2000 and 2001. Okay.
So, Mr. Callahan,
Yeah.
would you literally just fill X in as, like you do 26.6 times 2,000?
Yes.
And then...
Yes. Yes. So, in case there's like one or two that would like to see how you actually could use the calculator to its most advantage, because some of what we're doing right here, you know, I'm just trying to make it simple so we can just get it right. But this is how you could actually do this and use the calculator to do everything it could possibly do for you. Let me see, clear. So let me see if I got the stat edit. And that's not the right data, so let me put in the data. 95. I think that was it. Got to make sure I go all the way to the top here. And I'm going to go 1920. Okay, I have a problem there. 798. Okay, so I've got all my data in. Watch what I'm doing here. Some of you are getting pretty good with the calculator at this point, but this is just a little beyond, not necessary if you just want to write down the equation. But so I've got the data in. I make my equation, stat calc 4. Enter, 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 enter. Okay, and those are the same numbers that everybody got, right? So now, instead of writing it down, I'm going to go to y equals. I'm going to clear this, right? I go to y equals, and these are the steps. If you've got it in your calculator now, like go to y equals and clear out what you've got. So there's nothing there. And then notice this button right here. It's called vars, V-A-R-S. So I click on vars. And then number 5 says statistics, stat, right? That's what we're using. So we hit 5 for stat. And then at the top menu, it says EQ for equation. So we arrow over. And that first one, it says reg equation. That's the regression equation. That's what we just did. So when I hit 1, it's going to put that the equation on Y1. I didn't have to copy it somewhere. It's there already. All right. I don't think I have the plotting of points on. I do. So now if I go zoom 9, there's what you guys all got too, right? You had the line going through the points. Okay. Now, I'm going to let the calculator calculate for 2000 and 2001. Now, if I go to my, if I go to the table of values, right, and it starts at x equals 0, I would have to scroll down until I get to 2000 to be able to answer that question, which is going to take all day, right? So, I mean, I could do a couple things. If you notice above where it says window, it says table set. So if I want to make that table of values a little different, I can go second, table set. And I mean, I could just have it start at 2000, right? And now when I go to the table of values, 2000 and 2001 are just right there in front of me. I don't actually have to do anything. Okay, another thing that you can do, which is what I usually do because I use that feature a lot, is I go second table set, and then you go down to the line that says independent That means the independent variable, which in a function it's the x value, and I set it to ask. And then when I go to the table of values, it's blank. But I can put in whatever values I want. If I put in 2000, it gives me that one. If I put in 2001, it gives me that one. Right? If I want to do 2016, it gives me 2016. Right? So you can use the table of values just to give you exactly what you want, nothing more. Okay. So the things we got to know for sure, though, are how do you enter data? What are the steps to enter data?
Oh,
Stat edit, right? And where do you put the x's?
X equals
Where do you put the x's? Stat edit,
L1.
L1. And where do you put the y's? L2. How do you look at the data?
You have to hit
zoom on.
Okay, second y equals 1 for make sure the plotting of points is turned on, and then zoom 9. How do you make the equation?
You have to hit stat, calc, 4, and then hit.
Yeah, stat calc 4. Okay, that's it. And so for homework, it's going to be another worksheet like not the one you did for today, but the one you did before. Because in the end, the test on Thursday, if you could take 2 points and reliably make equation of a line, then you're in good shape.